Alright everybody, this is your video for factoring by grouping. This is used a lot in other methods, so you might always want to come back to this and make sure that you have this really solidified in your brain. So here's our steps. I suggest pausing, writing these down, following along with me, and also doing the examples in your notebook. So factoring by grouping, like I said, is used within other methods. So you might not see a direction say factor by grouping, but you know that that will be a part, especially in the A times C method. So you do this when you have 4 or more terms. So you can see that up here written in red, and I just underlined it. And that's what's letting you know that, okay, this is what I need to do. When I have 4 terms, or even any more than that, you need to group them into 2 groups. And it should make sense because that's the name, factor by grouping. So you can see here we have our steps and an example here as well. So the first one is to make them into 2 groups. So I'm actually just going to put parentheses on here. That red line was just separating them, but now you can see this is what our work's going to look like. Once you have them in 2 groups, you look at each group separately, and you're going to factor out the GCF. So in our first group, you can see that they have a 2 in common. They also have an x squared in common. So you can take out a 2x squared, and you're left with an x minus 5. When you look at our second group, you can see that you can have a 3 in common, nothing else. So you can take a 3 out. And remember, it's like dividing, right? When you're taking out that GCF, you're dividing it by 3. You're dividing 15 by 3. And you're again left with x minus 5. This is the best sign that you are on the right track when you're left with the same exact thing, okay? And that's what this third step here is saying. You should have a common factor. So these are exactly the same, x minus 5, x minus 5. You can write it first. We have x minus 5 here. And then you write what you've taken out, what you were left over with. So the 2x squared plus 3, they get put over here. Now notice that when we factor, we're breaking it up into terms that are being multiplied. There are no signs in between the parentheses now. It's understood that it's multiplication. So let's do a couple examples together. Alright, so our first example up here, you can see we have 4 terms. Actually, both of these have 4 terms. And that's already indicating that I need to group. This negative sign is with the 3, so always be careful with signs there. So now that you have these grouped, look at each group separately. When we're looking at our first group, I can definitely see that they have a 2 in common because they're both even numbers, 2 and 8. But as far as the variables, they're just going to have to stay. They're not the same, right? So I can't factor anything in common out. The only thing we can is a 2. So we're going to bring a 2 to the front. And remember, it's like dividing. So if I divide 2x by 2, you can even do a little in-between step. I'm left with just x. And then if I'm dividing 8y by 2, I'm left with 4y. So that's our first group there. Now our second group, I can definitely see that I can take a negative 3 out of each group. Now this one has multiple variables, right? But the one that they do have in common is a p. So you can bring a p to the front, and that means that we're going to be left with just x. And when you're thinking about that second term, when I take out the negative 3, it's going to be a plus 4. And when I take out that p, it's going to be left with a y. So again, this is a fantastic sign. When you have the same binomial or the same factor that's left over, we're going to write that first. So we have our x plus 4y, we're going to write that first, and then we write what we've taken out, so our GCFs. So it was 2 minus 3p. Alright, let's do the second example. So again, we have 4 terms. We're going to group them. Once we group them, then we can see what each group has in common. So when we look at this, we look at our first one and we say, okay, I can definitely take out a 3. And they both have an x squared that I can take out, right? I can't take out an x cubed because both terms don't have that many x's, right? So imagine that exponent, like how many you can take out. So 2 or 3, so the minimum, the common is going to be 2. When I think about dividing, I'm dividing 12 by 3 and I get 4, and x cubed by x squared, and that's going to leave me with 1x. When I take a 3 out of 9, I'm left with a 3, and I've taken an x squared out, so when I divide that, nothing's left. Now let's look at our second group. So I need this to look exactly the same as my first group on the inside, so that means that I'm trying to be left with a 4x minus 3. So right now, the only thing that these two terms have in common are going to be a 2, but I need to make sure I'm going to be taking out a negative 2 so that my signs are correct. So when I take out this negative 2, you can see now I'm going to be left with the positive 4x. And when I take a negative 2 out of 6, I'm left with a minus 3. That's what you need to be careful with. Signs are very important. When you're writing your final answer, write the binomial that you have 2 times first and only once. And then you can write what you were taking out. So the 3x squared minus 2.